All right, now we're taking a look at the other two amigos in trigonometry, sine and cosine. So what are sine and cosine? We last video talked about tangent, and I've done a brief introduction of these three. I just want to go in detail about sine and cosine. So again, they are two of the three trigonometric functions that involve right angle triangles. They, again, tangent is the third one. And sine, when you do the sine to an angle, the sine function to an angle, it gives you the ratio of the opposite over the hypotenuse side. Tangent gave you the ratio of the opposite over the adjacent side. So that's how they're different. Sine gives you opposite over hypotenuse. Cosine gives you the ratio of the adjacent over the hypotenuse. So if you don't know what I'm talking about, here's a triangle, and let's say that's the angle right there. If we know the opposite side and the hypotenuse side, that ratio, we know that ratio is equal to the sine of that angle. So the sine function works there. If we had the adjacent side to that angle, there's the angle that we're interested in, we usually call theta, we put a star there, doesn't matter. Adjacent side, hypotenuse side, the ratio of the adjacent to the hypotenuse, that ratio, if we cosine that angle, it'll be equal. Okay, so let's take a look at the sine ratio itself and how we got it. So the sine ratio, again, is useful when you're given the opposite and the hypotenuse side of a right triangle, RT, right triangle. So, and again, your calculator should be in what, like I said, mentioned before, it should be in degrees mode. Most of your calculators are, at this level, I'm pretty sure you know the difference with that. But if you're getting weird answers whenever you hit the sine button or in any trigonometry functions, then it could be because you're in the wrong mode. So show it to me if you have any problems with that. So here's a right angle triangle. And let's say that that side there is 3, that side is 5, and there's our angle, so that means that's the opposite, that's the hypotenuse, opposite hypotenuse, that means we're talking sine. If we were to, so that ratio there gives us a certain angle here, which we'll talk about in a second. If we do another triangle, if we double the opposite side and also double the hypotenuse side, you would get this, a 6 and 10. What is common about all these ratios? 3 and 5, 3 divided by 5 is 0.6, 6 divided by 10 is 0.6. And then if we do another triangle with the same ratio, 9 to 15, 9 divided by 15, trust me, is 0.6. The next one, 3 more added on to there, is going to be 12. And then 5 more added on is 20. 12 divided by 20, 0.6. So all these triangles, their ratio between the opposite side and the hypotenuse side is 0.6. So when we actually measure the angle, we measure it out, and trust us when we say this, it's 36.87. The ratio between the opposite and the hypotenuse is 0.6 for all these triangles where they all have the same angle. So what do you think is going to happen when we press the sine button and 36.87? Well, let's do that. The sine button. So again, there's our 3 buttons, and last time we did tan, this time we're going to do the sine button. So depending on your calculator, you punch the number in first or the button. On my calculator, I know I either punch the numbers in first, 36.87. Sine gives me 0.6. 0.6, which is the exact same of the ratios of all these triangles. So when you sine an angle, it'll be equal to the ratio of the opposite side divided by the hypotenuse side. Cosine does the exact same thing for adjacent and hypotenuse. So there's our triangle, 4 in the adjacent, 5 on the hypotenuse. So what is the ratio of adjacent to hypotenuse? 4 divided by 5 is 0.8. So what would be another triangle that would have the same ratio? Well, if we add 4 to this and add 5 to this, you'd get 8 and 10. If you add 4 more to this adjacent side and 5 more to that, you'd get 12 and 15. Notice all these triangles all have the same angle down here, right? And we keep going, 16 and 20. All of them have our same ratio of 0.8, 4 over 5, 8 over 10, and here 16 over 20, all have a ratio of 0.8. So again, we measure the angle, and you're probably wondering, what's so special about this number? Again, it works for other numbers as well, other ratios as well. 36.87, the ratio should be 0.8 between the adjacent and the hypotenuse. So if we were to do the cosine of that angle, what number do you think we should get? Well, if you've been paying attention in the last few lessons, you know that we should be getting 0.8. Let's try it. 36.87, 36.87. Cosine gives us 0.79999, which, yeah, let's just go with it. It's 0.8. And so when you have a cos of an angle, it would be equal to the ratio of the adjacent side to the hypotenuse. Okay, so that brings us to this, our notes here. So another summary again. So sine of an angle is equal to the ratio length of opposite and the hypotenuse, which means we get a formula for sine being the sine of an angle is the same as the ratio of the opposite side over the hypotenuse side. Opposite over hypotenuse. Remember, tangent was opposite over adjacent. And cosine of any angle is equal to the ratio of the adjacent and the hypotenuse sides. And so cosine is equal to, the cosine of any angle is equal to the ratio of the adjacent over hypotenuse. And like I said before, remember, tangent of any angle is opposite over adjacent. So now we have these three amigos all together, and we can talk about them, play with them, enjoy them. Come on. There they are, the three trigonometric functions. Okay, now, how do you remember all this? Are you going to know when cos is always that, and tan is always that, and sine is always that? Well, here's an easy way to remember it. So an easy, look how hip I am, an easy way to remember this is this. Sine is opposite over hypotenuse, so it's kind of like saw. Cosine is adjacent over hypotenuse, so ka. And tan is opposite over adjacent, so toa. Saw, ka, toa. If you write it like this, you can totally see, how that is opposite over adjacent. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Or if you don't like to write it out that way, you can just call it sakatoa. Sa-ka-toa. Say it a couple times. It feels good. Write it out a couple times. Sakatoa. Sine opposite hypotenuse. So you know that when you have an opposite hypotenuse, it's sine. Adjacent hypotenuse, cosine. Tangent is opposite adjacent. So let's use all these formulas now, all these trigonometric functions to figure out questions like this. So we're going from angles to lengths in these first ones. Let's say we have a situation like this. We have the angle here, and we don't know this length, and we know that length. Now to figure out which function we're going to use, sine, cosine, or tan, we have to know what sides we have. Now there's the angle. That is the opposite side. And this, because the boxy thing is pointing to it, is the hypotenuse side. So which of our three are we going to use? We have O and H, opposite and hypotenuse. O and H, that's sine. So we're going to use this formula. Sine is opposite over hypotenuse. this triangle, a little different. You've got the angle here. This next to it is the adjacent, and that's the hypotenuse. When to use adjacent to hypotenuse? Adjacent and hypotenuse are going to be A and H. That's cosine. So there are the two functions we're going to use. For this one, we'll use sine, and for that one, we'll use cosine. Let's first focus on this one here. So, again, that's why the first step is figure out label the lengths of the triangle. That's always the first step, is to label the lengths of a triangle. Then you figure out what formula you're going to use, and then you just sub in the numbers. So sine of 33, that's the angle we're talking about. So sine of 33 is equal to the opposite, we don't know, let's just call it x. The hypotenuse is 8.34. X is there, we want to get rid of the 8.34, so we're going to, it's being divided by that, so we're going to multiply by 8.34, and we'll do the same thing to this side here, 8.34. Now, some of you are thinking, shouldn't we sine this angle first? Yeah, you can. You can do that first, and then multiply by 8.34, or you can go 8.34 and then find the sine of 33. Either way, okay? I'll do it the old-fashioned way, that when I did it in the last video. First, what I did was I found the sine of 33, because some people don't like that sine thing. Find the sine of 33, so get rid of that. And the way I do that is get my calculator. 33 sine is 0.54. 0.54 is what I'll use there. 0.54 equals x over 8.34. Now I can do the cross multiplying. Multiply this side by 8.34. Multiply that side by 8.34. And the 8.34 is cancelled out on that side. X is equal to this times that. 8.34 times 0.54, and it gives me an answer of 4.48, rounding to two decimal places. 4.48. So what I just figured out is x, and x was the missing side up here. So that side is 4.48. Done. Let's use the cosine on this one here, because we have adjacent and hypotenuse. The cosine of the angle, we're looking at 58 degrees here, so cosine of 58. Adjacent is 4. Hypotenuse is x. If you like, you can, let's get rid of the cosine 58 first by doing the little stuff there. 58 cosine is 0.53. So that's 0.53 equals 4 over x. This is one of those weird ones where x is on the is on the bottom, and so this is where the cross multiplying comes in handy. That little trick where I showed you, and I kind of did here, but it was kind of easier to see. Here, when the x is on the bottom, we're going to do cross multiplying. Remember this? We turn both of them to fractions. That is already is a fraction. This number we turn into a fraction by putting it over 1, and we crisscross multiply. That is going to multiply that, and that is going to multiply that. Cross multiply, or diagonal multiply if you want to think of it that way. So that times that gives you 0.53x, and that times that gives you 4. Now you want to solve for x. Divide by 0.53, divide by 0.53. These cancel out, and 4 divided by 0.53 is 4 divided by 0.53 is 7.55. If we're going to two decimal places, 7.55. That is that right there, 7.55. We just figured out x is 7.55. Not a big deal. How about going from lengths to angles? In this case, when you have lengths to angles, again, label the triangle. There's the angle we're talking about. They're labeling it as theta now. And there's, of course, it's a right angle triangle. If that is the angle, then this side here, because it's right next to it, is adjacent. Some of you might be thinking, well, isn't that angle right next to it too? But remember, the boxy thing always tells the truth. The boxy thing always points to the hypotenuse. So we have adjacent hypotenuse. Which one of our three amigos are we going to use here? Adjacent hypotenuse is cosine, so katoa. So its cosine of the unknown angle is equal to the adjacent over the hypotenuse. Well, so again, we labeled the triangle, figured out which formula to use, and sub in our numbers. So cosine, we don't know what the angle is, but just call it theta, or leave it as theta. The adjacent side is 5.2. Hypotenuse side over here is 6. So we go, let's figure out this side, 5.2 divided by 6. 5.2 divided by 6 is 0.87 repeating. 0.8, the 7 was going on forever, rounded off. Well, 6 was going on, but we'll just call it 0.87. Just rounding it. And cosine theta. Remember, when we're trying to find the angle, we're trying to find what that unknown angle is. We're solving for the angle. It's being bugged by cosine. Do you remember what to do from the last video? How do you get rid of cosine? Well, this is the inverse thing. Remember, inverse cosine? The opposite of cosine was something called this. Cos to the negative 1. And the second function, or inverse, of sine will also be sine to the negative 1. So sine and sine negative 1, cos and cos negative 1, they're opposites of each other. Just like in the other video, tan and tan to the negative 1 were opposites of each other. So how do you get tan to the negative 1, sine to the negative 1, cos to the negative 1? Or inverse cos, inverse sine, inverse tan? Your calculator does that for you. Before we do that, let's get rid of this cosine by doing inverse cos here. Do the same to this side. When you do that, that gets rid of the cosine, and you're left with just theta. And then we have to go 0.87 of the inverse cosine. So here's how you do that. I know it sounds weird, but let your calculator do the work. So we punch 0.87, and then we want this. And again, depending on your calculator, you have to look for it and see how your calculator does that. On my calculator, there's sin cos tan. I hit the inverse button, and watch what happens to sin cos tan. I hit the inverse button, and boom, it switches it for me. So I want cos to negative 1, which is that. And watch what's going to happen to that. It should turn your answer into like a whole number degree value. And it does. 29.54. 29.54. I just figured out how many degrees that is. That's the degrees in that triangle right there. Done. Okay, how about these two triangles? There's the unknown angle. This is opposite. The boxy thing always points to the hypotenuse, so that's hypotenuse. I know I'm talking about the sine function here, opposite over hypotenuse. That's why I picked that one. And this is the cosine one because there's my angle. That right next to it is the adjacent side. The boxy thing points to the hypotenuse side. Adjacent hypotenuse, that's why I'm going to use that one there. So, let's do this one first. Sine unknown angle is 5, the opposite, divided by 7.8. So sine theta is 5 divided by 7.8. Well, what is 5 divided by 7.8? 5 divided by 7.8 equals 0.64. So we're going to 0.64. On this side, we don't know anything yet. Sine theta. I want just theta by itself. Remember, theta means unknown angle. How do I get rid of sine? What's the opposite of sine? Is the inverse sine. Sine negative 1 this side, do the same to the other side. Sine negative 1 of that. That cancels those out. We're left with theta. 0.64 inverse sine. So let's do that. 0.64 inverse sine gives me 39.8. We're going in two decimal places, 39.79. 39.79 degrees. That is the missing angle we were trying to find right here. There it is. Now to find that missing angle, cosine of the missing angle and the ratio we're looking at is adjacent 4, hypotenuse 7. So for adjacent I'll put 4, hypotenuse we'll put 7. 4 divided by 7 is what we're trying to find. 4 divided by 7, 0.57. So this side is 0.57. This is cosine theta. Oops, messy, whatever. How do I get I want to solve for the theta. I inverse cosine this side, do the same to the other side. These are gone, I'm left with just theta. And 0.7 cosine, or inverse cosine, is what I'll do here. So, bring out my calculator again. 0.57 inverse, right there, cosine. Stay away from these guys here. That's something else. Cos to the negative 1. No H. Not cosh to the negative 1, it's cos to the negative 1. Boom. 55.25 if we're rounding. 55.25. 55.25 degrees is what I just figured out there. And you can get a rough idea if you're doing it right. Your angle number should be, something like this. It's going to always be less than 90 because it's a right angle triangle, and the number of degrees in a triangle is always less than 180. The number of degrees in a triangle always adds to 180. And if that's 90, and there's two other angles there, that means your degree you're looking for is always going to be less than 90. So as long as your answer is between 1 and 90, you know that you're probably right. So that is the angle right there. 55.25 degrees is what we found for that missing angle. So there you are. Remember, saw, ka, hoa, SOHCAHTOA, 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 SOHCAHTOA. Use your friend SOHCAHTOA to help you answer these questions here. Let's fit it all in. So find the missing angle for these two, and then find the missing side length for these two. That's supposed to say 26. Okay. Hopefully this works out for you, and hopefully you're having some fun with this. Talk to you later. Bye.